I am Stephanie Shea Mitchell. I am in Tuesday's lab from 2 p.m. to 4:50 p.m., CHY 123, section 0035. And Sudhira is my TA. The first thing that I'm going to do in this experiment is to tare the balance. We do this by turning on the scale. You can see that this is set to 0.0. The next step is to measure the mass of the empty graduated cylinder. Now I will only be doing this once throughout this video for simplicity's sake. Our reading says 7.2. I will record that in the journal and the table that I've already made. For the next step, I will tare out the balance again. We do this by pushing the T button. This gives us a 0.0 reading. If we take the cylinder off, we get a negative 7.2 gram reading. The next step is to measure 2 milliliters of distilled H2O into our graduated cylinder. While you may not be able to see it in this video, I am lowering my head so that I'm able to gauge the meniscus properly. Our graduated cylinder shows 2.0. However, our balance shows 1.8. I will record this in the table in my journal that I've already made. I will continue this step for 4, 6, 8, and 10 milliliters. My head is lowered so that I can see the meniscus. However, while the graduated cylinder says that we are at 4, our balance says that we are at 3.7. I will continue this for 6 milliliters. Again, I'm lowering my head so that I can see the meniscus. We are right at 6 milliliters, but we have 5.8 grams. And again, I will record this in the table in my journal that I've already made. Now I'm going to fill my graduated cylinder until 8 milliliters. And again, my head is lowered so that I can see the meniscus. We are at 8 milliliters, but our balance says 7.9 grams. And finally, for 10 milliliters, again, I'm going to lower my head so that I can clearly see the meniscus at eye level. And at this point, we actually have a clear reading. 10 milliliters says 10.0 grams. At this point in the video, I am supposed to illustrate how replications were done in the table that we created. As you can see, we repeated each measurement for each graduated cylinder 3 different times. 1, 2, 3. Here we have the one for the 25 milliliters. This is for 10 milliliters. On the back page, this incomplete one is the one that I just recorded for the video, but next to it, this is the one for 100 milliliter graduated cylinder. Down here we have our horizontal axis, the x-axis labeled, the estimated plasticware volume in milliliters. Our vertical axis, the y-axis, is labeled calibrated volume in milliliters. You can also see here that I plugged in the values, these blue dots, for each of my corresponding values from my table. But I did also include a nice neat table up top for my lab report. And then I connected them with a line segment. As you can see, this graph shows us how to determine the calibrated volume of a graduated cylinder. As you can see, this graph illustrates that our graduated cylinder is slightly off from our balance, which is much more accurate. Well, that's it for me, Stephanie Shea Mitchell, CHY123, section 0035. Thank you so much for watching. Have a great day.